regular polygon. All angles and sides are equal or congruent. The center of a regular polygon is the center of the circle that is circumscribed about the polygon, or the center of the circumscribed circle. Circumscribed, that came back from chapter 5 in December. On the whiteboard here, I kind of have a regular hexagon. Circumscribed means the circle goes around the polygon. So that circle is circumscribed about it. The center of the circle is the same as the center of the polygon. Okay? The radius of a polygon is the distance from the center to a vertex. The radius of a regular polygon goes from the center to the vertex. The apothem of a regular polygon is the perpendicular distance from the center to the side. Apothem. Perpendicular from center to side. Apothem is perpendicular. Apothem is perpendicular. Radii are not. They're not going to make a right angle. Apothems will make a right angle. Apothems are perpendicular. Get it? Okay. Apothems are perpendicular. This morning someone said apothem sounds like a possum, and opossums hang upside down perpendicular to the tree. They do that too. Okay? So you can remember either link. But apothems will always be perpendicular. You have a picture there with rectangles that we have to fill in. This top rectangle is pointing to that point. What would you call that? The center. The middle rectangle is pointing to the segment that goes from the center to the vertex. That'd be your radius. Good. And then the apothem is the perpendicular segment. You have to make sure you know the difference between the radius and the apothem in your pictures, otherwise it's going to be hard to find your area today. Before I'm going to tell you your area formula, we have to know one other thing. 2 radii, the angle between them, that's called a central angle. So label that on your picture, central angle. Angle formed by 2 consecutive radii. It has to be the consecutive radii that make a central angle. The vertex of that angle is the center of the polygon. Central angle. The vertex is on the center. Since I have 6 radii in a hexagon, I would have 1, 2, 3, 4, 5, 6 central angles. 6 radii, 6 central angles. All the angles end up forming a what? It's a circle. How many degrees are in a circle? 360. So if I wanted the measure of just this one angle, I would take 360 and divide it by what? 6, and that would give me 60 degrees. So in a hexagon, a regular hexagon, your central angle will always be 60 degrees. Today, your polygons are regular polygons. All the angles and sides are congruent. The central angles are congruent. The apothems will be congruent. Right? You should see there right below this picture how to find the central angle measure. 360 divided by the number of sides. And below that would be your area formula. To find the area of a regular polygon, It's 1/2 A times P. Little a is the length of your apothem. P stands for the perimeter of the polygon. Sid, how do you find the perimeter of a polygon? How do you find the perimeter of a polygon? Yeah, you just have to add up all the sides. So you have to make sure you know the side length of your polygons so you can find the perimeter. And then you also have to know the apothem. Did you circle that or highlight that or star that formula on your worksheet? Notes? Do it now. Another one to add to your list of formulas from the other day. Before you can find the area, you have to know your central angle measures. So that's what we're going to do on the first two. Your picture looks like this. Yours isn't multiple choice. We're just going to go through the picture. Blue lines are going from the center to the vertices. So would that be a radius or an apothem? Radius, good. So angle 1 is formed between two radii, so I call that a central angle. How would I find the measure of that central angle? Good, 360 over the number of sides. Well, it's a triangle, so how many sides does it have? 3. So angle 1 is going to be 120 degrees. Central angle, 360 divided by the number of sides. These two radii at the bottom, they're going to be congruent. So that triangle at the bottom is what kind of a triangle? An isosceles triangle. From radii to radii, this entire angle is 120. When you draw in the altitude, what's it going to do to that vertex angle? Bisect it because it's congruent to this one. So then angle 2 is what? 60 degrees. Your central angle will be bisected by the apothem, always for any of these regular polygons. If this is 60, the other side would be 60, so angle 3 has to be what? 30 degrees. Triangle sum theorem, they have to add up to 180. Don't put B on your notes. That's not going to help you when you go back and look. List the angle measures out. Okay. All right. Try the next one, number 2. Find your 3 angle measures, 1, 2, and 3. Angle 1 is formed between two radii, center to vertex, so I'd call that a central angle. 360 divided by the number of sides, well, it's a hexagon, so what's 360 divided by 6? 60. The central angle for any regular hexagon will always be 60 degrees, no matter how big or small it is. Angle 2 is formed between the apothem and the radii, so that's going to bisect your central angle. So what's the measure of angle 2? 30. 60 divided by 2 is 30. So now I have 30, 90. What does angle 3 have to be? 60. You notice you have special right triangles there. You're still going to have to know your hypotenuse equals short leg times 2, long leg equals short leg times square root 3 stuff. Okay? You have to know that for this section as well. Flip it over. A library is in the shape of a regular octagon. Each side is 18 feet. The radius of the octagon is 23.5 feet. We need to find the area of the library. Okay. So we don't have a rule for octagons, but we have an area rule for a regular polygon, which is what was on the front side. For any regular polygon, the area is 1/2 AP. Little a stands for your apothem. P is the perimeter of the polygon. Sid, how do you find the perimeter of a polygon? Good. So how many sides does an octagon have? And what's the length of each side? Good. So can I just do 18 times 8 then? 144? Okay, so the perimeter of our octagon is 144. And the little a is your apothem. Would that be my 23.5 length segment? Nope. Which one is it, Franson? Which line should I label A? Good. The perpendicular segment, that's your apothem, so we're going to call that little a. Clean. How are we going to figure out the length of little a? Good. You have to use your Pythagorean theorem here. A squared plus 9 squared equals 23 and a half squared. I think after you square both sides and subtract, 471.7525. So when you square 9 and square 23 and a half and subtract 81 over, you should get a squared equals 471.25. Then what do I have to do? Take the square root to come out nice. Okay, so we'll just go to the 10th then, 21.7. Got your apothem, you have your perimeter, so now you're going to substitute it into your area formula. 1/2 21.7 times 144. Approximately 1,563 square feet. That's the entire octagon. So if our town had an octagonal library, they wanted to recarpet it, they would need to know the area of it so you can know how much carpet to purchase. Okay. All right. Number 2, or whatever number it is on the backside. Find the area of an equilateral triangle with an apothem of 8 centimeters. Leave your answer in simplest radical form. You're going to see this a lot more in this section than you have the first 2. When you see that, do not use what? SOHCAHTOA. Good. If you see radical form, no SOHCAHTOA. Either Pythagorean theorem or special right triangles. Okay? Okay. Equilateral triangle means it's equiangular, therefore it's regular. Your figures today are going to be regular polygons. 1/2 AP. Because it's a regular polygon. Any regular polygon is 1/2 AP. But it's a regular polygon, so it's still 1/2 AP. My apothem, they gave me that. What's it equal? 8. We have to come up with P. What's P stand for? Perimeter. In order to find the perimeter of the triangle, I have to know it's what? Side length, the S value. Okay, so, if you don't know where to start with your central angle measure. From radii to radii, that's a central angle. 360 divided by what? What did you say? I couldn't hear you. 3, good. Triangles have 3 sides. 360 divided by 3? 120. That's from radii to radii. What's the apothem going to do to that? Cut it in half. So then this angle here is going to be 60 degrees. This they already told me is 90, so this little one over here is, yep, 30. We have a 30, 60, 90 in there. 8 is which leg of your 30, 60? Short leg, because it's across from the 30. I need to know what this length is so I can find the whole side length. What leg is the bottom one? Long leg. In a 30, 60, 90, long leg equals short leg times what? Square root 3. So then this is going to be 8 square root 3. So the whole bottom, S, is going to be how long? 16 square root 3. That's your entire side length down there. Found my side length. Now I can find my perimeter. How many sides are that long? 3 of them. So you're going to take 16 square root of 3 times 3. All you multiply are the things outside of the radical. So 16 times 3, 48. So there's your perimeter, 48 square root 3. You have your apothem. You have your perimeter. Plugging it in up here, you're going to do 1/2 8 times 48 square root 3. Simplest radical form, no decimals. Half of 8 is what value? 4 times 48 then. So this would be 192 square root 3 centimeters squared. That's one way to find the area of this triangle. What kind of triangle is it? Equilateral. You could do that one thing where the area of an equilateral triangle equals the side squared times the square root of 3 over 4. Is that what we're talking about, Wiggly? Okay. For either way you choose to do it, we still had to figure out what S was. But now here, once you know S, you could say 16 square root 3 squared times the square root of 3 all over 4. And this value, when you plug it into the calculator, would still give you 192 square root 3. Okay? There's going to be multiple ways to find the area of triangles. You could actually also do 1/2 base times height on this one if you want to do 2. You can pick. You just have to show your work. Right, Dylan? Okay. Try number 5. Area of any regular polygon, you can use 1/2 AP. Jack, what's this little a stand for? Do we know that length? What is it? 8. Good. Jack, what's the P stand for? Do we know what it is? You do? What is it? How the heck did you get that? Good. Side length is 11.6. Pentagons have 5 sides. You said 58. So your perimeter is 58. So then when you substitute it in, 1/2 8 times 58, Jack, what'd you end up getting? Centimeters squared. Because sometimes you have to do things on your own. Next one, hexagon. You have to find the area of this one with a side length of 16. I'm going to let you try. All right, I think most of you are here. There's your 2 radii. And then you'd have to drop in your apothem there, kind of your starting point. Area equals 1/2 AP. We have to figure out what the apothem and the perimeter is. We should be able to do perimeter right away. 16 times 6, 96, right? Okay. Here's your apothem. From there, you have to have an angle measure to find anything else. So you need to find your central angle. From radii to radii, 360 divided by the number of sides, which would give you 60. So then this one tiny angle would be what? 30. Good. And then this one down here is 60. So my apothem ends up being my longer leg. And in order to find the long leg, I have to know my short leg. What would your short leg be? 8. Good. So if your short leg is 8, then your long leg is going to be what? 8 square root 3. So your apothem is 8 square root 3. Substitute it in here. 1/2 8 square root 3 times 96. Half of 8 is what? So 4 times 96. So your answer in radical form would be 384 feet squared. Yesterday, some of you used the regular hexagon rule without even knowing it was really a rule. I draw in my 2 radii. This radius would be congruent to this radius. Do you agree? Okay. The central angle, what did we come up with for an angle measure? 60. Since this is isosceles, these base angles would have to be what? Congruent at least, right? 180, take away 60 is how much? Cut that in half, what are these? 60. So this equiangular triangle becomes equilateral, so wouldn't all those sides be 16? Okay. How many equilateral triangles are there in a hexagon? 6. So, Wiggly, if we use that one doohickey that you were talking about, and one equilateral triangle, is side squared, square root 3 over 4, right? How many equilateral triangles are in the hexagon? 6 of them. For a regular hexagon, you can take 6 times side squared, square root 3 over 4. You might want to write that down somewhere on your paper. You don't have to know that rule, but had you have known that, all you would have had to do is take 16 and plug it in there and simplify. We wouldn't have had to do anything else. You can do it however you want. Yes, you would. Well, that's because you put square root 3 in the calculator, probably. No. Okay? If you want to know it, you can. It's a shortcut. You don't have to know it. Of a regular hexagon. This 6 times side squared, square root 3 over 4 works only on regular hexagons. Because regular hexagons have 6 equilateral triangles in it. So if I find the area of one equilateral triangle, I would take it times 6. Okay. All right. Go ahead and do the bottom two.